right, hey guys, we're going to be working on back to the basics, everything that you could ever possibly want to know about um, the basic periodic table structure, why it's shaped the way it is, how you get groups, how you get periods, or why you have those things, or what information you can get from them. So if you're struggling in any area of chemistry, this is the best way to go about it, and it's really essential that you understand these parts before you start going into ionic bonds and covalent bonds. So I'm going to start, and you should do the same thing. Grab a white piece of paper. I have just a plain sheet of white paper right here. I also have a copy of the periodic table with me, and you can get a blank periodic table off of eClass. It's just over there by itself on the left side, and you can have that so that you guys can practice and study and drill. We're going to draw several of the elements out. I should let you know we are not drawing the entire periodic table, so before you think I'm completely crazy, we're not doing that. So I'm going to start by drawing, today we're focusing on electrons, because a lot of the periodic table, first of all, is in order of atomic number. That is the number of protons. However, the electrons are super important. Their role, if you remember, is to bond with other elements. And so the way that they are organized on the periodic table with that crazy looking design has a lot to do with their number of electrons, especially what we call valence electrons. So I'm going to start with hydrogen. And I'm going to draw how many electrons does hydrogen have, first of all. Hydrogen has an atomic number of 1. If it has 1 proton, it also has 1 electron. So I'm going to draw the first shell around hydrogen, and it has 1 electron by itself. Okay? Now I'm going to leave a little bit of room for what we would consider to be the transition metals. Not as much room as they actually have. They actually take up 10 blocks going across the periodic table, but I'm going to leave that space there for right now, okay? And then I'm going to come over here and kind of catch up. So directly across from hydrogen is the only other atom that's on the top row, and that is helium. And helium has got 2 electrons. So I'm going to put a circle around helium, and I'm going to draw 1, 2 electrons. Okay, so there's 2. Now there's a couple of rules that you need to write down. First of all, the first electron shell can hold up to 2 electrons. Okay, that's super important. Once this shell has 2 electrons, it is full. It's different than the other shells. The other shells, and for right now, we're going to do everything with the number 8. Later on in the year, we might adjust that a little bit. But for right now, the second shell, and as far as you're concerned, every subsequent shell, so every shell after that, holds 8. So for right now, second shell holds up to 8 electrons. And always remember the phrase 8 is great. Okay, so that's the phrase we need to stick with for right now. So we're going to go down. This is going to complete the first row. We're going to go down now to the second row, and that's lithium. And lithium has got an atomic number of 3. So it has 3 electrons. So I'm going to put 1, 2 on the first row, first shell. But that shell is filled up. So what do? I create another shell. So I'm going to make another shell on that, and I'm going to put 1 electron on it, because all total, lithium has got 1, 2, 3 electrons. But when you start filling up the shells, you can only put 2 on the first shell and it's full. And then we start filling up the next. This can hold up to 8, but we don't need 8 there. Okay, so then we're going to come across here to boron. And boron has an atomic, oh, sorry, I skipped beryllium. Good job, me. So we're going to do beryllium. Beryllium has an atomic number of 4. So it has 4 electrons on the periodic table. So it's got 1, 2, second shell, 3, 4. Come across here, you've got boron. Boron has an atomic number of 5. So that's 1, 2, 3, 4, 5. I put mine in pairs. I've kind of always done that. It helps me visually to see who's missing a partner, but you don't necessarily have to do that. The next one, second one is carbon. Atomic number 6. So 1, 2, that shell is full. So go to another shell. 3, 4, 5, 6. Then nitrogen. Yes, I'm doing this whole row, so if you're working ahead of me, go ahead. Nitrogen has got 7, so that's going to be 2 on the first shell. 3, 4, 5, 6, 7. Then we have oxygen, which is always strange because it's just a circle. So on the first shell of oxygen, you've got 1, 2. We're looking for a total of 8. If you have 2 on the first shell, then you're going to have 3, 4, 5, 6, 7, 8 total. Then we're going to move on to fluorine. Fluorine has 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 1, 2, 3, 4, 5, 6, 7 on the outside row. 7 plus 2 is 9. And then the last one in this row is neon. So it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So neon's got a total of 10. So once we get to this one and you see that this one has a 10, neon has got 10 total electrons, but it has 8 in this second shell. That second shell is also full. So if we needed to have more, we would have to add another row. So that brings me to another definition that you guys need to be very familiar with. And I'm going to put that down here at the bottom, and that is valence. Valence electrons, or you could also say valence shell. Valence is the outermost, so it's the outside shell of electrons. That means if you have one shell, that shell is your outside shell. So for example, helium, its outside shell has 2 electrons. Neon, right below it, its outside shell has actually got 8 electrons. Fluorine has got 1, 2, 3, 4, 5, 6, 7 valence electrons. Oxygen has got 1, 2, 3, 4, 5, 6 valence electrons. Each one has a different number of valence electrons. Those are also important because, like, for a human, your life goal might be to get married or have kids or not have kids, to get good grades in school, to play a particular sport, to move to a certain country. If you're an atom, those are not your goals. Your goal as an atom is to have a full outside shell. Okay, so if you're an atom, and let's say that you're fluorine, for example, and your outside shell is the one that has 1, 2, 3, 4, 5, 6, 7 electrons in it. How many do you really want to have? You really want to have 8. So you're not quite happy with life. You're pretty happy, but not quite happy. Things could be better if you could just find that one missing electron. So that brings us to neon. So let's go down and do a couple more from the row right below neon. So right below that is sodium, who's pretty common. We use sodium quite a bit for various compounds. And let's do the first shell. Sodium has a total of 11 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that fills up that second shell. Now we're going to have to add a third shell. So these atoms are starting to get bigger, if you notice. Like their radius across the circle there is getting bigger. How many electrons go in sodium's outside shell? Just 1. Because you've got 2 plus 8 is 10, plus 1 is 11. And then the last one, maybe the last one we're going to do, don't know yet, is magnesium. Magnesium has an atomic number of 12. If you have 12 protons, you have 12 electrons. So 1, 2, second shell, 3, 4, 5, 6, 7, 8, 9, 10, third shell, 11, 12. Okay, and I lied. We're going to do aluminum really fast. So if you come over here, we're going to add aluminum. Aluminum has an atomic number of 13. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that's the last one we're going to do for all this. And I'm going to show you guys some easier ways. If you're like me, you get tired of drawing polka dots, and the polka dots are not always very accurate. Like if you look at aluminum, it's starting to get pretty big. It's got 3 shells, and you have to be really careful and make sure that you count everything. You know, you've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have the right number of polka dots, but it can get confusing and it's easy to make mistakes. So instead of doing this to figure out how many valence electrons you have, there is a much easier way. You should start to notice what we call trends on the periodic table. And trends mean that once one thing starts to happen, it kind of happens in all cases in that area, or it happens all the time, or it's common. So for example, hydrogen only has 1 electron. It means that its outside shell, the only shell it has 1 valence electron. If you come down here, lithium has 3 electrons, but how many valence electrons does it have? 1. So hydrogen has 1, lithium has 1. Now if you come down here, you've got sodium. Sodium has 11 electrons, but also how many valence electrons does lithium have? It has 1 valence electron. So if you're looking at valence electrons, you've got 1, 1, 1. The next element down here is potassium. Can you predict how many valence electrons potassium would have? If you said 1, you would be correct, because it turns out that everybody in group 1, that would be potassium, rubidium, cesium, and francium, all have 1 valence electron. And that's how you draw an electron dot diagram. You just draw a dot for the valence electron. So if you are in group 1, it is safe to say that you have 1 valence electron. Now, if you go to group 2, you've got 4 for beryllium, 4 total. How many valence? 1, 2. Go down to magnesium. How many valence are there? No matter how many total electrons, there are 1, 2. That means you could probably predict a trend in this group right here. The trend would be that all elements in the same group, that means magnesium, calcium, strontium, barium, and radium, all have 2 valence electrons. So we would draw that like this if we wanted to add the electron dot diagram there, just so we can kind of see what's going on. What group is this? It's no coincidence that's group 2. I bet you can predict that as we go across the table, we skip the transition metals. They do not follow the same rules. Just because they're in a certain group doesn't mean they have a certain amount of valence electrons. That's a different section altogether. When you skip that and you come over here to group 13, notice that you've got 1, 2, 3 valence electrons, and you've got 1, 2, 3 valence electrons. The reason it's 3 and not 13 is because we subtract for all these transition metals. So this is going to be group 3. You can probably figure out that carbon is in group 4. Nitrogen has 1, 2, 3, 4, 5. Oxygen has 1, 2, 3, 4, 5, 6. Fluorine has got 1, 2, 3, 4, 5, 6, 7. He's super close to being satisfied. And then over here, helium has 2, but neon down below there has 8. and that's group 8. Everybody underneath neon, that would be argon, krypton, xenon, yeah, xenon, and then radon. They all have 8. Everybody over here is 8. If you remember, they have a certain name. They are called the noble gases. Okay, so everybody over here, except for helium, has 8. The reason that's important is that helium, even though it doesn't have 8, it has a full outside shell. So the fact is that he's just as satisfied having 2 in the first shell as they are having 8 in the outside shell. Okay, so if somebody's trying to figure out how many valence electrons that there are in an atom, you do not have to do all this art and make it look so crazy. All you have to do is go, okay, well, if you're in group 1, you have 1. If you're in group 5, you have 5. So if I asked you guys how many valence electrons does astatine have, which would be kind of around this area somewhere, you would look and go, oh, well, it's in group 5, so it must have 5 valence electrons, and you would be correct. There is also one other clue that you can find from looking at the periodic table the way that we've done it. If you notice over here in group 1, hydrogen has 1 shell. It's also not a coincidence. It's in period 1, row 1. Lithium has got 2 shells. It's a little bigger, row 2. Sodium has got 3 shells. It's in row 3. How many do you think potassium would have? If you said 4, you would be correct. Rubidium would have 5. Cesium would have 6. And francium would have 7. So there's ways that you can figure out everything across the periodic table by taking shortcuts. And the reason that the periodic table is organized the way that it is designed to help us get the information such as how many valence electrons and how many shells does an atom have. And the reason that shells are important is because what do you notice about the size of the atoms as you start to go down the periodic table? You should recognize that they're getting bigger and bigger and bigger. Okay, that has to do with electronegativity, and we'll pick that up in the next video. So I hope that this was helpful for you guys.